Hi, welcome to the Indie Wine Podcast. My name is Matt Wood, and this is episode 86. Today and the next couple episodes, we'll be presenting the recorded panels from Unfiltered, Conversations About Wine. It took place on July 26th at Donkey and Goat in Berkeley. Jared Brandt of Donkey and Goat has always been passionate about wine education, and together with Andrew Sullivan, they put on the first annual version of this festival. Their aim is to elevate the status and awareness of our local natural and low-intervention winemakers, doing this through community and education. It's always been a pet peeve of mine when local wines aren't represented on local wine lists, whether retail or restaurant, especially when local produce can be featured so much on restaurant menus. The Thursday night Unfiltered events at Donkey and Goat are morphing as well. Guests will be able to sit down and speak in depth with winemakers in a small group setting, asking questions and hearing a lot more background info as each wine is presented. Carrie Q Wines will be there August 7th and Six Cloves on August 14th. This first panel, Adaptation, attempts to answer the questions, are low intervention and natural winemaking increasingly incompatible with sustainability? What will winemaking in the region look like as temperatures rise and rainfall patterns shift? Will there be more spraying, different vineyard canopies, more mechanization, possible genetic engineering, different varietals, or different elevations or aspects? Derek Trowbridge of Old World Winery moderated the panel, hosting guests Dr. Con Cottrell, formerly of UC Davis, now producing his own wines, and Dr. Wendy Silver and Dr. Tibsay Perez, both of University of California, Berkeley, and Matt Neese of North American Press. I hope you enjoy. A reminder that I have a Patreon at patreon.com/indiewinepodcast. The link is in the show notes also. If you're enjoying the podcast, any amount to help me keep telling wine stories ad-free and available for everyone is appreciated. It's all run independent and out of pocket. Telling a friend or sharing on social media are great ways to help out too. One last thing, we overlooked having an audience mic for the Q&A, so the questions towards the end came out a little low in level. So it's going to be me asking them on this episode, but they are the audience questions. Okay, here we go.
Okay, John, but it's still going on.
Oh, yeah, no, John.
He's intimidated.
Hey, everybody. I just want to make a quick introduction. This is the first in our lecture series today on adaptation. It's pretty much an incredible panel of people here. You've got, obviously, Derek Trowbridge, who could give a lecture on his own on this topic, who's one of the great long-term advocates of sustainable farming and viticulture in this area. We've got Wendy Silver here and Dr. Silver and Dr. Tibsay Perez from UC Berkeley, who are also specializing in sustainability and soils in particular for adaptation in agriculture and viticulture. We've got Matt Neese, who's a super interesting personality and great winemaker, who's saying we're making all the wrong grapes. Basically, we're growing the wrong grapes, and he focuses on hybrids and native vines that are more climate resilient. And we've got Dr. Con Cottrell here, who's ran the experimental vineyard at UC Davis for many years and is using some of the science that the results of his studies to make his own wines out there. It's Cottrell wines, which you can taste right outside. And I just want to make a note that Jared Brandt has played an incredible role in shaping the whole look and feel of this event. And part of Jared's goal is to elevate people's understanding of wine when they're drinking wine, right? Whether it's understanding of the winemaker and the personality of the winemaker and how that expresses through wine, varietals, or just baseline education. So this lecture series embodies kind of Jared's approach to the joys of wine, and a big part of that is education, learning, and community and dialogue. And not everybody agrees, right? And so it's also about different opinions on this. So I'm super happy. Very proud to hand this mic over to Derek Trowbridge.
Hey, thank you, Andrew. Thank you, everybody, for being here. And what a great intro. Appreciate you, Andrew. And do we have somebody to pour wine? Did everybody bring glasses to taste a few things if we pour them for you? Okay, well, we could get started with that just so we get the protocol going. And then I'll just sort of introduce what we're going to do, and then our speakers are going to do it. Yeah, just either one of those two, or both of them. Yeah. They're same one. And then we'll talk about the wines in a minute. Well, actually, I'll just introduce it now before I introduce the whole thing. So this is a 2017 vintage. No, 2015 vintage. Got it right there. Okay, so we'll get it for you when you go. Great, thank you so much. Yeah, you got to open. Yeah, please. And then just two, I think. Two is fine. Sorry, I'm talking in the mic. I'm talking to Matt. We're getting this set up. We're all meeting for the first time to do this panel for you today. Not meeting exactly for the first time, but anyway. So this wine, 2015 vintage, Syrah, 100% Syrah. It's a vineyard that's no longer here. We lost it in 2017 due to the 2017 glass fire. I could talk more about that, but I will just leave that there. That's a part of adaptation. What are we adapting to? And my farming technique, which is using mulch under the vines, except for the mulch is flammable. And so it will, it doesn't catch fire, but it smolders. And so what happened was when I showed up after that fire, you can just set it right here, Con, right here. Yeah, just right next to that if you would. Yeah. When I showed up, we had vines that looked like they could be pruned, but they were all melted off of their roots because of the mulch. So, some of our strategies for adaptation can be problems later. We'll get into that. What we're going to do is each person's going to do about a 10-minute kind of intro of what they do. And then we're going to, rely on you guys to deepen this conversation. We're going to try to leave 20 minutes. We got an hour. We're going to fit a lot into an hour with all these speakers. And we want you to, thank you. We want you to ask questions. So be thinking of your questions. I'll introduce each panelist as we go, and then they'll give a talk, and then we'll hold questions until the end. I know it's harder to remember. Hopefully you got a pen, you can write your question down. But it's better, then we can all free up and let it free flow on the questions. So setting the stage for the panel, and then I'll hand it over. And each of you has your own mic. Behind you, they're all live. And they're professional mics, yet they're to your right. And so you can depending on how you want, you can talk really close or really late. Yeah. So depending how you want to do that. Okay, so this is the adaptation panel, in case you didn't know which panel you showed up for. And I'm gonna put I thought the way they posed this panel, the way Andrew posed it was really great. Are low intervention and natural winemaking becoming incompatible with sustainability? These are great conversations to have because, anytime we have a solution, we need to think about what is the total sum of that solution, because it affects more than just what we expect it to. What happens to winemaking in the region as temperatures and rainfall shift? Will spraying increase? What about mechanical harvesting? What about vineyard canopies, grapevine genetics, and so on? And so we'll just start it there. Doesn't mean the panelists are necessarily going to address all that. They're going to address what they do. But and so let me introduce, before I hand it over to her, let me introduce Dr. Wendy Silver. She's the professor, she's right here to my left, professor of ecosystem ecology and biogeochemistry. I love that word. In the Department of Environmental Science at UC Berkeley, her work seeks to determine the biogeochemical effects of climate change and human impacts on the environment and the potential for mitigating these effects. She's been the lead scientist of the Marin Carbon Project, which we all owe a homage to, which is determining the potential for land-based climate change mitigation, particularly by composting high-emission organic waste for soil amendments to sequester atmospheric carbon dioxide. I will hand it over to you, Wendy. Thank you.
Okay, thanks. Is this live? You guys can hear me? Great. So I am not a winemaker. I am a wine drinker. Okay, good. So some of us are in the same boat here. And I'm a climate change scientist. So I want to talk to you a little bit about climate change and a little bit about what the future is going to look like and ways in which we can alter our behavior, and particularly in agriculture, to adapt to that future and help mitigate climate change. So climate change is here. Last year was the warmest year on record globally, and it was over 1.5 degrees Celsius warmer than pre-industrial temperatures. That's above what the target was for the globe, the Intergovernmental Panel on Climate Change, the group of scientists that are trying to synthesize where we're going with regard to this. So that's a big that's a big benchmark we just passed. Climate change it's happening. It's here. It's not a thing of the future. It's not a hoax. And it's something that we're going to have to deal with, whether or not our federal government is interested in participating. The last decade was the warmest on record. In 2011 to 2021 was the driest decade in California history. And I'm sure people who grow wine grapes understand this well. And we know why climate change is happening. It's happening because we're putting greenhouse gas emissions into the atmosphere through our activities, primarily fossil fuel combustion, but also agriculture. And that's leading to an increase in these heat trapping gases that then re-radiate that heat back down to the planet. And we experience warming, and that interacts with a lot of different aspects of climate. We know we're on this trajectory to warm, and this intergovernmental body that keeps track of these kinds of things had a really great quote in a report recently that said, a large fraction of anthropogenic climate change resulting from CO2 emissions is irreversible on a multi-century to millennial time scale. So that's the bad news. We're heading in this direction, and some of this is irreversible. But the next sentence is, except in the case of a large net removal of CO2 from the atmosphere over a sustained period. So think about it this way. Carbon dioxide concentrations and other greenhouse gases are increasing. We have to lower emissions, but what's that going to do? It's just going to slow down the rate of increase. We're still increasing. So we need to couple that decrease in emissions with carbon dioxide removal. How do we do that? We do that potentially through our agricultural activities like wine grape growing, and other agricultural practices. We've been working a lot in rangelands and in croplands. And what we're doing is working with plant growth, which is photosynthesis. Plants use CO2 as a resource to grow, convert it into solid carbon. And so as plants grow more, they pull more CO2 out of the atmosphere. Some of that gets shunted into the soil. And if it gets shunted into the soil, it has a higher probability of sticking around. So soil carbon is good. It tends to be a longer duration carbon, which means it has a longer impact on slowing climate change. How do we manage that? How can we increase the amount of carbon stored in soils? Well, the Marine Carbon Project and my lab has been working a lot on looking at composting. So taking high-emitting waste streams like animal waste, green waste, food waste, composting that, and then creating this nice slow-release organic fertilizer that can be land applied. And what we found over the last 15 years is that when we apply this to different types of ecosystems, including vineyards, there's now a lot of data from vineyards that suggests that we increase the water holding capacity, the plants grow better, they suck more CO2 out of the atmosphere, and we end up slowing climate change. Our data has suggested in rangelands that we can sequester about, on average, a metric ton of carbon per hectare per year. And that may not mean much to you, but if we could do that over just half of the rangeland area in California, we would offset all of livestock emissions and all of landfill emissions. And if we can do 1 metric ton per hectare per year, like we're seeing across our research sites, across half of California's land area, we would offset all of agriculture and still some. So the potential is quite high. There's a lot of reasons why land managers might want to do this. If you increase the organic matter content in your soil, of course, you're increasing the fertility, the water holding capacity, and the stability of soils. So there's lots of co-benefits that go along with this. All of those co-benefits help make these ecosystems more adapted to climate change. So it helps them survive the heat events and the drought events. So I will stop there and I'll hand it back to you and take questions later.
Awesome. Thank you so much, Wendy, for giving us the depth of the understanding and some details. It feels like I really appreciate the incremental growth stages, because it's this whole idea is obtuse. You can't really have this conversation without talking about where carbon is, where it's been, that it was stable for 10,000 years before we changed it in the last 150 years, and what it's going to take to bring that back. So appreciate you. And also thank you for keeping us on time. All right, so let's go over to Tibby. So Dr. Tibby Perez, she's with the UC Berkeley Department of Environmental Science. Her focus is on climate change, atmosphere, biosphere interactions. I love that term as well. And alterations of greenhouse gas fluxes due to land use change, as well as the effect of agriculture and urbanization in biogeochemical cycles. Please take it away, Tibby.
Thank you, Derek, for the invitation. And it's a pleasure to be here with such knowledgeable group of winemakers. Thank you. I want to first start talking about the importance of knowing that any activity that we do, we produce waste. But we could potentially think about it as those problematic solutions that we have to take with the waste that we generate, transform it into a climate-smart resource. So I want to talk a little bit about the work that we've done in Wendy's lab about how we transform waste management into a potential solution. I work in I haven't worked as Wendy says too. I haven't ever worked in the winery industry. So I'm coming from a large background in greenhouse gas emissions from agricultural land and for waste management at a compost facility in Nicasio Valley, where we measure greenhouse gas emissions from different composting processes, different composting matrix. We used in an experiment that we did there in a facility scale experiment, we composted food waste. And what we found was very striking. We found that composting food waste would reduce from 34 to 84% the greenhouse gas emissions that could have happened if that food waste would land in landfills. So it's really significant. And this could be potentially extrapolated to the wine industry. If we think about the wine industry as a whole, globally, we produced in average about 77 million tons of grapes globally. About half of that is required, is aimed to produce wine. In California alone, last year, it was about 3 million US tons of wine grapes that were produced. Grape pomace is, better than I, is the residue that you guys have to deal with after pressing the grape. And they could represent about 20 to 30% the total mass of your grapes. So what to do with that? And it could be a climate-smart material that we could use. So Sonoma and Napa has already having the initiative of taking the pomace to a composting facility to process and to create animal feed. But we could think about this a little bit further. How about if it's composted on site? We will decrease the emissions related to transporting this large amount of pomace to the facilities, and then you could incorporate the derived product from your composting on site, and we could apply to on land in the vineyard to produce your slow release fertilizer. That in itself is a benefit, but it doesn't come like that easy because grape pomace is acidic, so you will produce a low pH. But it's recently a study, I was searching the literature, and I found that study did 50% composting of grape pomace with food waste, and what it ended up, it neutralized the acidity of the compost derived, and also it improved the nutrient content of the product that was generated. So this could be an alternative that not only you could dispose of your wine production waste, but also the food waste that is produced locally. So that could be also an alternative solution that will decrease also the greenhouse gas emissions derived from that activity. Another thing that it could be done, which is another alternative, is to have the investment of having an anaerobic digester on site. That has two benefits. You could generate power because you could produce methane. And to get the rough numbers out there, if you have a production that in a winery that produces like 1,000 tons process 1,000 tons of grapes. A ton of pomace could produce about 94 kilowatt hour of energy. So that means that if you have an operation that processes 1,000 tons of grape per year, you might be able to offset about 45% of your energy demand for your operation. So it's pretty significant. Of course, this needs to be assessed with experiments to definitely test it, right? For the local area that to show your local conditions, right? And then the leftover production of anaerobic digestion is the digestate that is left over from that process, and that digestate has a lot of nitrogen content. A lot of people use it to fertilize the soils directly, but has the problem that it could be emitting ammonia, and that impact local pollution, right? So an alternative could be to compose that digestate, and that digestate is rich in nitrogen, and you could also apply it on site. So these all alternatives, it's just a few that we could do from the agricultural management perspective that could increase the circular economy principle, but also the sustainability in the long term, so that we could provide, return back to the land what the land is giving us. And with that, I will leave the floor for questions when we're done. Thank you.
Awesome. Thank you so much, Tibby, and also keeping us on time. These are great points because I don't know, you all may not be so aware of the regulatory world. I've been a composter for 15 years, and I tried to start a company called Soil Carbon Management doing regenerative soil amendments. And you have to sort of do it illegally at first because it's hard to get a permit. And of course, I got caught doing that. And the county really doesn't like to see piles of what they call waste carbon products that are either ag or forestry waste. Mostly what I'm using is wood chips and of course my winery waste. And there are limits to what you can legally do, but there is legislation that just passed that increased the amount of on-farm composting that's a reality. So you can legally, right now, before that came into play, it was like you could have 150 square feet, like 300 cubic yards of material, which is nothing. You could use that in a half an acre to do regenerative farming. And so it's what she's offering, what Tibby's offering is that now there is more room in the regulatory world. We're realizing that farmers can take some of this material, do good with it, double good, use up a waste product, but also get it on the soil where we need it, right? We need it. We need that microbiology. We need that carbon to pull that carbon out of the sky. So thank you, Tibby. All right, moving on to Mr. Dr. Khan. Do I have that right? So we've got a good blend of industry and science here, and Khan combines both. He's got a big academic background. He's also in the industry world doing his own winemaking and farming, and then consulting on farming. And so Dr. Khan Kirchherr, he studied plant physiology and was a professor at Fresno State and UC Davis for a total of 18 years. He worked with wine grape growers in all districts of California on topics including climate change mitigation. And he was mentored, I love this fact, mentored by the late Fred Franzia, who, people don't love in Napa, but I met him when I was at Fresno State, a really smart man that, saved this industry before this current downturn by using up boatloads, pond loads of wine. So I thought that was interesting you had that. I'll hand it over to you.
Yeah. Fred's the one who brought me to California. I was originally at University of Kentucky enjoying life. But then I came here through some sort of recruitment. But anyways, so I agree with what the other panelists have said. Climate change is not a hoax. It's here. So when I was hired at UC Davis, the first project I was asked to do was figure out how to, slow down this desiccation or dehydration of the berries on the plants. So, everything is irrigated in California. We have a, very good climate, very rich soils. So we went back to the drawing board and looking at all the knowledge we had, we realized that, maybe some of these trellis types we were using were not the correct types for our climate. Everyone, reads the back of the wine bottle saying like, oh, it's Mediterranean climate, etc., so on and so forth. But a majority of our industry is focused or concentrated within a 100-mile radius of Fresno. Whether you like it or not, that's the reality of the situation. And it's not a true like a Mediterranean climate that does not have the influence of the ocean. So with that in mind, we looked at how we can change or have some effect on the growing practices. So initially, we shaded the canopy with a shade cloth, so that provided some relief. But mainly, changing the trellis types that we use, going to a more of a procumbent trellis, a tall trellis where grapevines can sprawl, was the most amenable to our conditions in California. So I know the industry is in a downturn at the moment. Not too many developments going in, but 80% of the developments going in are going into a single high wire system where the grapes can be protected from the sun. Of course, irrigation is a big issue in California, but not as much in wine grapes. You're looking to use about 1,000 millimeters of water on the in the coast, north coast. That's not that big of an issue. But if you go to central coast and inland, where you might only receive about 6 to 8 inches of rain, that is a problem. So Derek said, I'm sorry, Wendy said rain patterns have shifted. They have shifted. We're still receiving the same amount of rain, but it's coming at an inopportune time for grape growers. So this 2.5 acre feet of rain has to be supplemented somehow. Although we do not have the shortage of water, we do lack the energy to convey it. So I think that's going to be the bigger issue moving forward. Looking at the quality of grapes that's coming out through this climate change, we are right at the apex now, but it's going to come down eventually because grapes do not like solar exposure and heat directly on them. So we are seeing this decoupling of sugar accumulation and phenolic accumulation in the grape berries. So that's going to be the biggest issue to overcome at the moment. So I'll turn it over to hybrids, my first love.
Con, do you want to introduce the wine that we're just now pouring the?
Oh yes. I think Wendy alluded to it. Federal funding, the federal government is walking away from our research. So I kind of got this feeling a couple of years ago. I left the university world, and we have a small vineyard in Davis, about 40 acres. So there, we're working with a lot of these new products, mainly protein hydrosylates, peptide-based products to grow our grapes. We're not using synthetic fertilizers. So I have this Chardonnay product this is the first one we released. So it had about 3 months of exposure to French oak. Then we took it off and bottled it. So it's our Chardonnay from Solano County. It turned out quite good. It's got this little crisp minerality to it, and I think we were able to extract whatever we could from this very unforgiving clay soil that we have in Solano County. So that's our wine. So
awesome, thank you, and thank you for also keeping us on time. Our speakers are doing an amazing job making room for questions. So I hope you guys are building some questions right now. And that leaves us with Mr. Matt Neese, our sort of West Coast master of the hybrids. This is a thing that gets talked about on the East Coast more so than out here. And, a lot of wineries, in this area just sort of poo-poo the idea. It takes a trailblazer to want to focus on that and actually become known for it, as Matt's brand has been known. The his background, he went from nearly a decade of making Burgundian wines at Radio Coteau to starting a wine brand dedicated to native grape species called North American Press. And his background includes professional cooking and structural engineering. I always find it's interesting. You got to know everything about the person, and that makes him who he is and why he's a trailblazer. And he's going to offer some of his experience here. Go ahead, Matt. Oh, and we got 2 wines here. As soon as that one's poured, we got 2 more for Matt, or one wine, but 2 bottles.
Thank you, Derek, for the introduction. Thank you all for being here. It's wonderful to be invited on this panel and be with these folks who are much smarter than I am about all this. But I don't necessarily have the academic background as the other panelists, but what I can provide is my real world experience from growing the grapes that I grow. So I can just tell you, from a firsthand primary source of, what it's like to work with these particular grape varieties. We can back up, and I think it helps to understand like why or how I got interested in this. Initially, I was just interested in like native California plants. There's preserving the genetic diversity of where we live, basically. And for example, in my house, my whole front yard is all just native California plants. And besides this like romantic idea of making my yard look actually like it belongs in California by using the native plants that have evolved to grow around where my house is, there are so many other reasons to be doing that, in the name of sustainability, whether just less inputs, less water, less resources, increasing the biodiversity of your yard. And so that concept, like that's the concept, but now that doesn't have to just end at like your front yard. I mean, and so I'm driving to work, making in 9 years at Radio Coteau, and I'm just driving to work like I do every day. And I'm just driving by literally hundreds of acres of grapevines. And it just kind of like hit me like, why I got this tiny little yard? I'm like getting on everybody's case about growing native California plants. And then there's like thousands of acres of European grapevines. And I'm like, well, what about like native grapes? Like, are there any native California grapes? I mean, I literally had no idea. And so I went to work and I got on the computer. I was like, native grapes, California. I was like, oh my God, there's freaking native grapes to California. And we're not like making wine from that? Like that just blew my brain apart. And there's 2 native grapes to California, Vitis californica, which is in the top half of the state, and then Vitis jordiana. They call it the desert grape in the southern half of the state. And then so that was the opening of the rabbit hole. And then I'm still down in the depths. So I went to the library and checked out a bunch of books, trying to educate myself on American grapes, native vines, American viticulture. And a lot of these books are old textbooks from when this was more commonplace and I guess more accepted, kind of before like the boom of the California wine industry. And it was just called American Grape Culture, and it was how to work with our own native grapes. And then during Prohibition, a lot of these vineyards got ripped out. And then it just became the native grapes kind of lost the height of their popularity happened, and they never really were able to regain that. And European wine varieties became more popular, and anyways, the California wine industry. And so I just became fascinated about this idea of like, well, everyone talks about native grapes and how they make terrible wine, and I just kind of had this hunch, like, well, wait a second, like, what about AVAs? We have all of these amazing wine growing regions, like for a reason, and it's because these are the best places to grow grapes. And so, what, like this hybrid wine that you told me about that you said was terrible. I mean, like how was it made? Like, where was it grown? Like, who was the producer? And like all of these things matter, And so I just I was on this journey just to strip away all the variables and just say grapes are grapes. Let's work. I want to work with these native grapes. I'm just curious about it. I've never honestly even had, at the time I didn't know what Foxy was. I mean, you hear the term thrown around, you go to school, you go to like enology school, and there's like, a chapter about hybrids, and it just talks about like foxiness, and then like that's the end of the story. And so, but I didn't have the firsthand experience of it. So anyway, so I came across this Baco Noir vineyard in Sebastopol, and it's 60 years old, totally dry farmed, no irrigation, has never been sprayed with any chemicals whatsoever. And it's just Sebastopol. So the mildew pressure is not, by California standards at least, the mildew pressure is extremely high. So if you're conventional, you're probably, spraying once every 10 days-ish. And if you're organic, you have to spray even more, like once a week and so here's this vineyard in West County. There's a lot of fog that rolls in the morning. There's a creek that runs right by the vineyard. The weeds get ridiculously tall. There's not a lot of airflow. It's a very vigorous vine. By all means, like these vines should be riddled with mildew, and they look amazing. They're healthy and green and vigorous. And so initially it was just like this concept of like this romantic idea I've had of like, I want to make American wine made from our own indigenous grape species to, again, like preserve the genetic diversity of our own grapes and make a more like quote unquote authentic American wine from our indigenous flavors. But then all of a sudden it was like, wow, there's like so much more to this story. Now there's like, you don't have to use chemicals. Like I don't have to come out here and spray like 3 a.m. Like now there's like, that is a lot of that. There's a lot of implications in that. And while I didn't get a degree in enology, I did take a couple winemaking classes at the JC. And there was a sustainability course. And, they talked about, there's like three main tenets of sustainability. Economic, environmental, and social. And to be truly sustainable, you have to meet all 3 of those. And here I am looking at this vineyard, and I'm like, there's no chemicals used in this vineyard. So there's no chemicals in the runoff. There's no chemicals being sprayed onto the actual grapes itself, which going back to your guys' conversation about the importance of not having the importance of the compost and using the pumice for your compost. Well, now your compost doesn't have any of these chemicals in it either. And there's more and more studies coming out where they're talking about the effects of fungicides, and that even if they're organic fungicides, they're still, you're spraying for mildew, but then there are other like downward effects of using these chemicals, namely on like insects and stuff. So maybe you're spraying for mildew and you're not having any mildew, but then there are other effects that are affecting the insects that are on the vines. And so here's this vineyard that is I mean, it's hard to explain the biodiversity of this vineyard. I mean, I see, a lot of critters and animals every time I'm in this vineyard. And so there's less chemicals in the environment, there's less chemicals in the watershed, there's less chemicals on the grapes, in the compost. And then, I don't have to come out here and spray. So there's less material costs, there's less labor costs, there's less tractor passes, which means less diesel costs, there's less soil compaction. And then there's the social element where, the wine industry is built on underserved communities. And the Latinx community is the backbone of this industry. And they're out there in the vineyard they're the ones that are being subjected to these chemicals. So there's this social element where now you're not subjecting your vineyard workers to these chemicals either. So it pretty easily checks these boxes of these 3 tenets of sustainability. And so now it's like, okay, well, that's cool. But I heard that these grapes make terrible wine. And so how am I going to do? So I just, so that was the project, was like, let's grow these grapes and let's see what happens. And what I have found, and what you guys are drinking right now. So this is Lenoir. This is one of the oldest grapes in North America. It was discovered on the East Coast by the French Huguenots, and it made its way west and eventually found its home. It actually went across the pond and became well known in Europe. They call it Jacques in Europe. It found a home in Texas. They call it Black Spanish. And then it was one of the first grapes planted here in California, called Lenoir. There was 3 main hybrids that were initially first planted in California: Lenoir, Isabella, and Catawba. I work with all 3 of those. So this is I'm not doing anything new. Hybrids have been in California for a long time. It just kind of isn't really talked about. So all of the historical vineyards of California that like Morgan Twain Peterson and Tegan Passalacqua are working with, a lot of those vineyards have Lenoir in the field blends, in these old historical field blends. And so what I've done is we've taken cuttings from Pagani Ranch, which is one of these historical vineyards of their Lenoir, and then grafted it into a vineyard in Lake County. And that's what this is. So this is cuttings taken from 120-year-old Lenoir vines in California. And so I don't know. I don't think it tastes that bad.
Right on.
I don't know if I went over my time.
No, you're good. You're good. Thank you so much.
Yeah.
All right. Well, then let's dive right in. We've got like a little over 15 minutes to do some questions. Anybody have one coming right up? I saw your hand first.
I wanted to ask about hybrids. Can you talk a little bit more about hybrids and how they might affect the wine industry going forward?
Well, I spent about like 7.5 to I would say 9 years total working with hybrids, French American hybrids. Now there's like American hybrids as well. Um, uh, when I think about climate change and how it can be mitigated, hybrids are not going to be as resilient as the European grapes in our climate, because a lot of them were hybridized with the European grapes. They're going to be more resistant to diseases, especially diseases and herbivory that might be coming from soil. When you look at the hybrids that we can grow here, they are the ones that can resist some of the untoward elements. Our biggest issue in California is the sun. I mean, it's hot here. You can look at the back of the wine labels. There's everyone's claiming a cool climate. We're not cool climate. Yeah, I mean, you have to protect yourself, so the grapes have to be protected. If I had the money at the university, I would do one of these trials where I would put on this garden. Where I would compare these against the European varieties and see which ones are more resilient. Because if you look at the literature, everyone's comparing water use efficiency of these hybrids to traditional European grapevines, which they call the true grapevines. Take it or leave it. But water use efficiency is kind of a misnomer, because if you stress them, water use efficiency goes up higher. So everything is going to be very water use efficient if you don't irrigate them. But hybrids, they are going to be more tender than your European grapevines, because a lot of the grapevines we grow are coming from the Mediterranean basin. The hybrids, they were hybridized in northeastern United States. They're not used to these climates. But that being said, you could trellis them to be more resilient. But as he alluded to it, you're going to be emitting 26 pounds of carbon for each gallon of diesel fuel that you burn. So like this year, mildew is horrible. Like, he says Sevastopol. Like in a normal year, people would like spray 5 to 6 times. They're already at spray 13. So that is the so I mean, this is a very energy dense business. So and the diesel, farm diesel is $3.98 a gallon now. So if you did like an additional 7 sprays, it's going to be difficult to like mitigate all these things. So we're not going to win any wars against like mildew by keep planting these European grapes. But working with Chambourcin, Vignoles, Lenoir, I mean, in my opinion, in California, Treminette would probably be the best instead of trying to grow Sauvignon Blanc and dusting and spraying these 17 times a year. I think that'd be a good alternative to trying to grow Sauvignon Blanc, in my opinion.
And just in case, one second, just in case you didn't, you're going to come in on that, but let me just clear up one thing. In case there's confusion, so hybrids are Vitis, the European grapevine, Vitis vinifera, and, different North American varieties. Here in we've got Californica, and we've got Vitis aestibalis and Vitis rotundifolia, which are outside of California. Just so you understand, hybrids are different. They've got Vitis in them, and that's the basis of what he's offering.
Yeah.
Go ahead, Matt. You're going to say?
Oh, I was just going to follow up on your Treminette thing. So we did a small trial at Alder Springs Vineyard up in Mendocino County, where we trialed Stuart Bewley, the vineyard operator and owner up there. So I have these little trials all over California, basically, where we're trying to figure out which varieties are going to do well. And as he was alluding to, the sun is a big part of that. And so, like with the Baco Noir vineyard, for example, the vine is vigorous enough to where all the fruit is completely covered in the shade, which actually makes a much more complex wine. But anyways, back at Alder Springs, we trialed like 10 different varieties with the idea of trying to figure out which ones are going to do best at that particular site. And the top 2 contenders were Treminette and Vidal Blanc. So we are now expanding. We did. We grafted it this spring. So now there's a block at Alder Springs of 50% Treminette and Vidal Blanc, and it gets co-fermented or gets picked together and co-fermented together. Yes.
Okay, let's see. So
Treminette is a Gewürztraminer is where the Traminer comes from. So the Treminette comes from Traminer so it has some of those flavors, but it's much higher in acid. So it's not like a flabby version of Gewürztraminer. It's actually the opposite. It's aromatic, not as aromatic as Gewürztraminer, but it has some of the same flavor profiles, but much higher in acidity.
perfect. I saw a hand in the back. Any concerns with rootstock?
What do you mean by concern? Like, yeah, I understand. Yeah, got it. Understood. Yeah. So the Baco Noir vineyard that I have is own rooted because the guy who planted the vineyard in the 1960s understood that these are native vines and I can just stick them in the ground. But I don't own my own land, and all of these grapes that I'm sourcing from, it's not my property. And so it's a relationship, it's a conversation that I'm having with the grower. And at the moment, I have not found a grower that is willing to put some random native vines on their property in case this doesn't work out, and then they got to get pulled out. So most growers are like picking the rootstock for their soils. Obviously you can factor in the variety, the scion that's going to get grafted onto it, but majority is, the rootstock is picked for the soils, regardless of what variety is grafted onto it. If I had my own land, yes, I would just own root them all.
That's a whole nother conversation. We could talk about own rooting later. I do that as well. Yes, Ed.
Just to back up
a little bit. When you said you approached the vineyard and first started working with it, and there was no mildew pressure, and the vines were pristine, the DNA and nature of the hybrids, the vines are just purely resistant to mildew.
Correct. Yeah. So there are like 20-ish, correct me if I'm wrong, different grape species in North America. There's grapes, in native to most states. And a lot of these grapes, just because of the nature of like where the colonies started and westward expansion, a lot of the grapes that were initially worked with were grapes from the East Coast, or the Midwest, where the mildew pressure is extremely high. I mean, nothing compared to California, right? And so these grapes have just evolved in what's the word I'm looking for, to coincide with these mildews. And so they have a natural inherent resistance to the mildew, literally in their DNA. And so when you plant a grape that is used to being rained on all summer in the Midwest, and you plant it in California, it's like, it doesn't have to lift a finger to resist the mildews here, which is how I'm able to not use any chemical sprays.
In your winemaking process with this particular wine, did you do anything different than you might have otherwise done in terms of native yeast or fermentations or whatever?
With this Lenoir in particular. So one thing about hybrids too, which kind of touches on the sun conversation, is that, yeah, we're in California, and so, but luckily a lot of hybrids, especially the Riparia-based hybrids like Frontenac Noir, Frontenac Blanc, Baco Noir, Marquette, they are really high in acid, and that's what you want. If you're a hands-off, more natural-leaning winemaker in California, you want high acid grapes. You can pick earlier and earlier and earlier, but then you lose that full ripeness of the flavors. And so I kind of have almost the opposite problem, where I'm waiting until like the last minute to pick. So like, for example, this Lenoir. The Lenoir is a little bit of an anomaly, but the Baco Noir is a better example. So I pick it at like 23.5 bricks, and the TA is like 11. But a lot of that acid is malic, and so the conversion during MLF is like pretty dramatic. But this Lenoir, so in addition to really high acid, hybrids, a lot of the hybrids, one of their parents, whether it's their dad or their mom, is a wild American grape. And so, which means like high color, high acid, rough around the edges. And so with the Lenoir, the color is like so intense, and the flavor, and there's tiny little berries, and the flavors are so intense that for this particular wine, I press it off dry, and then it finishes in tank, because I'm looking for less extraction. I don't want this tiny little really intense berry at full 14% alcohol extraction. That's not really what I'm doing. And so I get the extraction of like, let's say an 11% wine. So there's like 11% alcohol in the fermenter, and then I press it, and then it finishes in tank. And so that helps preserve like the prettier aromatics and the make a more restrained wine, I guess.
All right, well, I'll throw I don't see any hands up, so I'll throw a question out for our researchers. So this would be for Wendy. So Wendy, I just want to bring it back to some other people. So there's a thing online you can look up. It's called 4 per thousand, the number 4, PER, the number 1000.org. It was created out of the Paris Climate Accord. And what they're saying is that if we take all the farmland in the world, so that's a big ask, but it's also a small amount of land, right? Most of the land is in rangeland and cities and whatnot. So farmland is one of the least amounts of land left. And if we took all that and raised the organic matter by 4 per thousand, which to us would be 0.4%, we like to use the term percent, we would negate all the emissions from humanity in 1 year. That to me was a huge statement. I love the website. I've used it in different things that I've offered, and I offer it here as a substance for bringing the conversation back to climate, and saying, what do you think about that? You know, I make a soil amendment. We bring the organic matter up from 1% to 4%, which would be from 3 to 10 times the amount that they're asking. So if we had fewer growers doing that kind of thing, we could raise the organic matter, sequester more carbon, that kind of thing. And so I just want to throw that out there to you, Wendy. And I see one of our next panelists is here. We're just going to keep rolling this until they kick us out. And so we'll keep going with these questions. So think of a question if you don't have one, and you'll come up next. But Wendy, do you have a comment on that?
Yeah, wouldn't it be nice? It would be so awesome if we could just say, well, let's all just put a little compost on our ground and we'll stop climate change. We'll reverse climate change. And unfortunately, from a scientific perspective, you know, it was a couple of scientists who came up with this, but it was there's been, and that led to a flurry of research and modeling and people trying to dig into where did this number come from. There's been a couple of others out there. I'm sure people see it in the press periodically that, oh, if we only did this to soil, we could stop climate change. And none of those have, there is, and I mean, it's bad for me to say this with my name, but there is no silver bullet, right? There is no silver bullet. There is a silver portfolio, though, of solutions. And so we can come up with lots of different types of approaches that together can have a big impact. And soil and carbon sequestration is definitely one of them. And it's low-hanging fruit, it's easy, and it has all these co-benefits. Right? So there's absolutely no reason and many reasons why we should be doing this, but it is not the solution of climate change. There's a lot of things I could get into where, adding organic matter, especially if you're not composting it, can lead to big greenhouse gas emissions that weren't accounted for in that we call it 4 per mil or 4 per thousand estimate. And so there's unfortunately that wasn't the most rigorous scientific activity that came out of the Paris Accords, but it certainly got people thinking about soils. So in that way, it was good. And soils are definitely part of the solution, but they're not going to stop climate change. Sorry.
Awesome. Thank you. Go ahead. Someone that hasn't spoken yet.
Has there been any analysis? I'm sure there has been, but I'm curious what the current analysis is of cover cropping versus disking, year-round cover crop, carbon sequestration, obviously like more water use, but more carbon sequestration. What's the kind of, at least for California, where we are?
Right. So we did an analysis recently where we looked at different agricultural activities that have been shown to sequester carbon. Disking actually often results in the loss of carbon, at least initially, right? You're disturbing the soil and you're breaking up the clods, and the microbes kind of have a feeding frenzy, especially immediately, and then you get a lot of emissions to the atmosphere. There's some evidence that you can actually displace some carbon below deeper into the soil and sequester it there, but on average, it comes out about either a loss or about equal. Cover cropping definitely increases. We compared cover cropping, enhanced weathering, which is this putting round rock onto agricultural soils that people are doing now for inorganic carbon capture, compost, agroforestry, so planting things in between the rows. Compost actually came out ahead. It sequestered more carbon than the other activities, but cover cropping certainly helped increase carbon. It was much smaller, though, much lower amount. But again, if you think about it as a portfolio approach, and you do what's right on your land in your area and with your economics, then all of those things can contribute.
I want to offer two things on the tail of that. One is Wendy helped design something that ended up becoming the Comet Farm Planner. I don't know how you feel about that now, but you can look up Comet Farm. Comet is in the comet going across the sky, and you can take a number of different farming techniques and throw them in there and find out what sort of general number they created for carbon sequestration. And number two, let's make this clear, in case it's not, that agriculture. Thank you. Agriculture is in the top 5 gross polluters in the world of carbon to the atmosphere. And why is that? It's because of tillage. It's not tractors. When you till, there's a model, and I don't know what you think of this model, Wendy, there's a model online, I forget what it's called, but it shows the amount of carbon being emitted off the land in spring when the farmers in the Midwest and everywhere are tilling the soil out of green, and the amount of carbon that activity, because what it does, the science behind it is it's oxidizing carbon. The carbon gets oxidized and goes back up into the atmosphere. Wendy, do you have a comment on this?
Yeah, I would say absolutely. And with regard to the farm planner, that's a very simplified model, and we struggle with that a bit on my side of the equation. But regardless, it's a good first step. The plowing is a huge source of carbon to the atmosphere, and inorganic chemical fertilizer is another huge source of greenhouse gas to the atmosphere, and especially the timing of those things really make a difference. So,
And you mean production of those? You don't mean putting them on the land, but you mean production.
oh no, I mean putting them on the land. You get huge. In fact, the nitrous oxide is the most potent of the three main greenhouse gases, and inorganic fertilizer is the largest contributor globally. And in the U.S., we add 50% more fertilizer to our land than our plants need.
So let me just contextualize that real fast. Nitrogen, 2 minutes. Nitrogen gets released from over nitrification of the soil, and that becomes a air pollutant.
So if I can add to it, so we compared Fresno County to Napa County with cover crops, disking and no disking. Like Wendy said, it's a wash between disking and no disking. When we compared different species of cover crops, if you introduce a cover crop where it's a barley or one of these fancy mixes that are about like $8 a pound to put in, your native cover crops, spontaneous cover crops are going to sequester more carbon per square meter than the introduced ones, because usually the natives will outcompete them. But our biggest offender was the UAN 32 when it was injected through the irrigation in the spring. That was the biggest efflux of greenhouse gases into the atmosphere. I mean, it was, you can smell it as it's going through the irrigation system. And we used to work in these like huge vineyards, like each row is 2 miles. These like 2 mile by 2 mile vineyards in Central Valley. And, they like bring tanks as big as just like a warehouse. Like this is like, very dense nitrogenous like fertilizer. And you have to like truck this and produce this. The amount of like energy that goes into these systems is immense. And none of it is produced here anymore. Everything's coming from China on a boat. It's a very interesting thing.
That seems like a fitting place to conclude out of respect for our next panel. Please join me in a round of applause for these amazing speakers. Thank you for all your work. Thank you.
Thanks for stepping in. We've got the next panel on terroir. All these are being recorded by the Indie Wine Podcast, and he will be rebroadcasting them as a future episode of his podcast. So if you like what you heard or you want to tell a friend, we'll be sending out emails with links to those podcasts after.
Thanks for listening today. Unfiltered was a great event, and the educational aspect added a really great twist to it. Stay tuned because the 2 remaining panels will be releasing in the coming weeks on the podcast with the themes of terroir and does natural wine romanticize flaws? I think you'll really enjoy those also. Links to everyone on the panel are in the show notes, by the way. You can follow the podcast on wherever you're listening and the Instagram at Indie Wine Podcast, and feel free to email indiewinepodcast@gmail.com with comments, questions, or feedback. If you're enjoying the podcast, I'd love if you told a friend or wine lover about it and help spread the word. Rating, reviewing, or donating at patreon.com/indiewinepodcast helps too. It all goes to offsetting podcast expenses like gas money, podcast hosting, research books, and websites, and allows for more episodes. We'll be back soon with another episode. Have a good one.